Hi everyone. Now it is the continuation of chapter 2, that is from the module 1 of engineering mechanics. So it is with the principle of superposition of forces. We can see there is a sphere, there is a force which is acting on the sphere. The force which is acting on the sphere M, we can see at the right hand there will be of the another force which has been existed as A. The same way F2 and F1 there will be of two forces which is acting on that single sphere, and at the end what we are getting, the output will become a1 plus a2. That represents there will be of net effect of forces on one particular point. The sequences on a body is given by the algebraic sum of the effect of individual forces on the body. That says that f2 and f1, that will become a1 plus a2 at the other end. It is nothing but the same force which is acting on that particular sphere, but at the end what you are getting, the resultant, that will be the same, but the force what which exactly acts on the opposite sides will be the different. But what you'll get, the output will be represented in some of the alphabets, just like a1 plus a2. Then the principle of transmissibility of forces. The point of application of a force on a rigid body can be changed along the same line of action, maintaining the same magnitude and direction without affecting the effect of the force on the body. We can see here there is a rigid body. It is nothing but the body which is at fixed. The sphere which is kept on the floor. Here we can see there is a force. If there is a force, there will be a four important points to be remember: the point of application, direction, the magnitude, and the direction. We can see here the direction which is acting from point A, and the force is acting on the sphere. And if you want to find out, and we can see the line of action, that is from the force where it is acting at A, and M represents the mass of that rigid body. And here we can see that, and we know generally if you want to find out the force, it is mass into acceleration. So now we can see that if you want to find out acceleration, it is force by mass. The same way, what is the force which is acting on that particular mass, and where it has been transferring, that we can see here, and that is on the point B. And the point of application of a rigid body can be changed along the same line of action, maintaining the same magnitude and direction without affecting the effect of the force on the body. Then the limitations should be remembered on the principle of transmissibility. Principle of transmissibility can be used only for rigid bodies and cannot be used for deformal bodies. We should be remember that the very important limitation of principle of transmissibility, it is only used for rigid bodies. It is nothing but for fixed bodies. That cannot be used for deformal bodies. Deformal bodies, it is nothing but the body which is going to be breakdown. Then the assumptions made in engineering mechanics. So there are five important assumptions to be remembered. The first one, all the bodies are rigid. That is in engineering mechanics. Particle concept can be used wherever applicable. Principle of physical independence of forces is valid. Principle of superposition of forces is valid. Principle of transmissibility of forces is valid. So what are all the points we have discussed in the basic concept of engineering mechanics that has been considered here? It will be as the assumptions. Then move on to the system of forces. And next is about system of forces. A group of set of forces is called system of forces. It is nothing but if it is there will be of a group of forces which is acting, we'll say that will be a system of force. So we can say that what all that groups belongs to the system of forces. That is the first one, coplanar force system. And we can see here the sketch. The force is acting in different directions. The lines of action of forces forming the system lie in the same plane. If you are saying coplanar, in the name only the answer will be there. The number of forces which is acting in a single plane, or it is in the same plane. So if the lines of action of forces forming the system which has to lie in the same plane, then the system is said to be coplanar. And non-coplanar forces, it is opposite to that. If the lines of forces, if the lines of action of forces forming the system but do not lie in the same plane, that system of force is said to be non-coplanar. And our study is restricted to coplanar forces. Then collinear force. So the collinear force system, we can see here F1, F2, F3, but all will be in the different direction, but will be the same line. If the force is the system having common line of action, then the system is said to be collinear. We can see that there will be of number of forces. So here there are three forces, F1, F2 and F3, but three forces acting in different directions, but all the forces which lie in the same line, or we can say single line, we'll say that will be a collinear force system. Then the concurrent force system. So the concurrent force system is nothing but there will be of number of forces but which has been passing from a single point. So if the line of action of forces for the system pass through a common point, we'll say the point of concurrence, then that system is said to be concurrent force system. There will be of number of forces but which can act in a single point. It can be in different directions, but it should be started from a single point. We'll say that will be as concurrent force system. The non-concurrent force system, if the lines of action of forces forming the system do not pass through a common point, we'll say that will be as non-concurrent force system. Then parallel force. So if a particular case of non-current force system in which the line of action forces forming the system are to be parallel. It may be of same direction or different directions, but the forces should be in parallel to each other. Then a resolution of force, we can see that resolution will be done through x-axis and y-axis, that is in terms of two-dimensional. The force F is producing simultaneously x displacement and y displacement, that is in terms of x-axis and y-axis. The part of the force F which is producing x displacement is called as x component, or we'll say that will be as horizontal axis or the horizontal component of forces. Then the part of force F which produces y displacement, that is in y axis, we'll say that will be as y component forces, that is in Fy and Fx. The technique of finding component of force along the direction is called resolution of force. So if you want to resolve any kind of force, that should be resolved in terms of x and y. It is nothing but if there is any inclined force, that should be resolved in terms of x component and y component. So to resolve a force along any direction, we can see here OA represents the force F both in magnitude and direction, that is theta, the acute angle made by the force with respect to the direction. X component of a force given by the product of magnitude of the force and cosine of acute angle made by the force with respect to x direction. Then y component force by the product of magnitude of the force and sine of acute angle made by with respect to x direction. And here the very important note to be remembered, the sign conventions. If you want to resolve any kind of force, the very important part is we have to remember the sign conventions. Here we can see there is an horizontal line which is moving horizontally right side, we'll say that will be as positive, and if it is moving opposite to that horizontal left side, we'll say that will be as negative. You can do vice versa, but we should be very familiar with this sign conventions while resolving the force. And if it is vertically upward, we can say that will be as positive, and if it is vertically downward, it can be called as negative. The horizontal, and the one more is the moment. The moment is nothing but it is force into perpendicular distance. So that can be taken clockwise as positive and anti-clockwise as negative. These 3 points should be remembered. Sigma h, the number of all the horizontal forces, will be taken as horizontally right side as positive. Sigma v is equal to 0, number of all the vertical upward as positive, and sigma m at one point will be equal to 0, that is clockwise moment will be as positive. The horizontal component or x component of force acting along the direction is force itself, whereas its vertical component or y component is 0. If a force is inclined at 45 degree with respect to x-axis or y-axis, then its component will be equal. We'll say that will be as fx and fy will be equal when it is equally distributed. Okay, these are all the 3 important points to be remembered before going to the numerical. Here we have the numerical, the problem number 1. And in that there will be of 3 sub parts, that is find x and y components, what we have discussed now. Find x and y components of the forces in the following cases. See here we can see there is an inclined force with respect to horizontal, the angle of inclination is 30 degree and the force is 100 kilonewton. So now we have to find out what is fx, that is the force in x direction, and we have to find out the force in y direction. If you want to find out in terms of x and y, if the force is inclined, we have to look over the angle of inclination. Here the angle of inclination is 30 degree. If you are saying the horizontal component or the vertical component, so with respect to the angle of inclination, opposite part is sine theta and adjacent part is cos theta. So we should be very much familiar with respect to the trigonometric functions, that we should know sine theta is equal to opposite by hypotenuse and cos theta is adjacent by hypotenuse. So here if you want to find out what is fx, so hypotenuse is 100 kilonewton and adjacent is opposite that line. So opposite line is fy and adjacent line is fx. So now fx will be 100 cos 30 degree. The angle of inclination is 30. So 100 cos 30. Then you'll get that will be as 86.60 kilonewton. So why are you getting positive sign? Because it is moving horizontally right side. Then fy, we can see the point of application and the direction. So then the vertically upward component, that will also will become fy, that is 100 sine 30 degree. Then that will become 100 sine 30. Sine 30 is 1 by 2, so I'll get 50 kilonewton. So fx is 86.60 and fy is 50 kilonewton. Then move on to the second one. Here we can see, so the previous one, the angle of inclination is horizontally 30 degree, and here it is the angle of inclination is vertical 30 degree. Then now again we have to draw the line will be as horizontally right side, vertically upward. Then that will become fx is 20 cos 70, that will become 6.840 kilonewton, and fy is 20 sine 70, that will become 18.79 kilonewton. Or you can use the third one, another one which is inclined. The angle of inclination is not given, but the side slope is given as 3 by 4, that is vertically 3 and horizontally 4. We can say tan theta is opposite by adjacent, so that will be written as 3 by 4, that is vertical by horizontal. 3 by 4, that is 36.87 degree will be the theta value. Now fx will be, so we can see the direction 200 Newton which is moving in this direction, line of action, horizontally left, vertically downward. Then this part will become horizontally left will be minus 200 cos 36.87, that will become minus 160 Newton, and fy is minus 200 cos 36.87, that is minus 120 Newton. So we can see that minus sign indicates that is horizontally left and vertically downward. So this is the way to resolve the component of forces when it is inclined in terms of x and y components of the engineering mechanics problems on the forces, system of forces. So now all of you, after watching this video, you can take n number of problems. You can just take with respect to different examples and solve it yourself. And if you are having any doubts with respect to this type of numericals, we'll discuss with the discussion session. We'll call for the Zoom meeting. Thank you.